Hey guys, Mr. Milton here. Today we're going to look at Introduction to Inequalities notes. At the end of this video, you should be able to determine whether a given number is a solution to an inequality, and you should be able to find and show all solutions to an inequality. All right, so we're going to start off. It says find the solution to the following equation. Okay, so we have 3x minus 4 equals 11. If we're going to solve this equation, we would say 3x minus 4 equals 11. We would add 4 to both sides. Okay. And then we'd have 3x equals 15. And divide both sides by 3. We get x equals 5. Okay, let's walk through this now. When finding a solution, we are looking for any number that makes the equation true. Okay. In other words, the left side of the equal sign has to be equal to the right side when you plug in the number. And so that's what all that whole process was. When we plug in 5 here, 3 times 5 is 15. 15 minus 4 is 11. 11 equals 11. Okay, what about inequalities? Okay, the prefix in means not. Okay, so therefore inequality means not equal. Okay, when we look at these symbols, make sure that you understand what they mean so that you don't have to say the caret to the right or the pointy thing to the left. Okay, this is going to be greater than, less than, greater than or equal to, and then less than or equal to. And then finally, this one you'll see is not equal to. Okay, just crossing out an equality or equal sign. Okay, so if a solution to an equation is any number that makes the equation true, a solution to an inequality is any number that makes the inequality true. Okay, and the difference is that with an inequality, there is with an equation, there's one solution. Okay, while with inequalities, there are many solutions. I'll even should say infinitely many solutions, but I'll just say many. Okay, so let's look at some examples here. It says, of the numbers listed, circle the ones that are solutions to the inequalities. So here, the first one we have n is greater than or equal to 9. So as we look at these different options, A, 6. 6 is not greater than or equal to 9. It doesn't work. B, 13. 13 is greater than 9, so it is greater than or equal to 9. Negative 25, less than 9. D, 9 is greater than or equal to. So it's not greater than, but it is equal to, so it is greater than or equal to. Number 2, we have 6 is greater than h. Okay, so we want to find an h that's less than 6. So 2 is less than 6, so it works out. 6 is greater than negative 18. Yep, I'd rather have $6 than negative $18. 6 is greater than 15. Nope, I'd rather have $15 than 6. And 6 is greater than 6. For number 1, 9 works because it's or equal to, but for number 2, 6 will not work because it doesn't say 6 is greater than or equal to h. It says 6 is greater than h, and it will not be greater than 6. It won't be greater than itself. All right, number 3, we have p squared plus 3 is less than 28. And so in this problem, we want to make sure that we plug in our values and simplify the left side. So on the left side, we have negative 9 squared. Remember that anytime you do that, you want to make sure that you use parentheses in your calculator, or you can just know that if I square a negative number, it's going to be positive. But when we do that, that's 81 plus 3, 84, not less than 28. 3 squared is 9. 9 plus 3 is 12. That is less than 28. Negative 5 squared is 25. 25 plus 3 is 28. So it's equal to, and so that fits. And then 30 or 6 squared is 36 plus 3 is 39. That's greater than, doesn't fit. Okay, so the point of this, seeing how we can check our answers, but then more seeing that there are many answers that work for an inequality. Okay, there's going to be many solutions there. All right, moving on to the next page. All right, here we go. Backside of these notes, it says, since inequalities have infinitely many solutions, it is impossible to list them all out. Okay, we need a way to show all these solutions, and the way to do that is to use a graph. You have to shade one side of the number line that to represent all the solutions. Okay, so here it says shade all solutions to each inequality. Here we have x is greater than 7. Here's how our line looks. I have a line, and it can be pretty simple. The number 7, I usually like to mark where 0 is because that shows me where less than or greater than or anything is. Okay, here we would use an open circle, and then we would shade everywhere where x is greater than 7. So I'd say, is 0 greater than 7? No, I don't want to shade in that direction, and I want to shade to the other direction. Maybe I should use a different color since I have one easily available to me. All right, number 2, we have m is less than or equal to 1. Again, I'm going to use my number line, use number 0 just to help myself out. The number 1, go over it with a different color. All right. So as I make my dot, in this case, I'm going to close it. Okay, no space in between. And then I'm going to shade where 0 is, 0 less than 1. Yep. So I'm going to shade in that direction. Okay, and I just draw this arrow to show that it keeps going. Okay, notice the differences here. The first problem, we went this direction. Second problem, we went the other direction. First problem, we have an open circle, and the second problem, we have a closed circle. Okay. When do you use open circles? Okay, you use open circles when you are either given greater than or less than. What about closed circles? Greater than or equal to or less than or equal to. Okay, basically when it's or equal to, we're shading that circle to let everybody know that that number is a part of the solution. When we leave the circle open, we're basically saying as close to this number without actually being this number. Okay, because if x is greater than 7, 7.00001 is a solution. Okay, so we use that open circle just to make sure that we are saying as close to the number as possible. Okay. Do not use shortcuts when you're shading. Okay, there's some people that are like, oh, well, if I just put the variable here, if I just do this, then I have to follow the arrow. Just think about it. Okay, I gave you one way to do that. I think about where the number 0 is, but there are, I mean, if you just think about numbers around it, it works out. Okay. All right. So show all solutions to the inequality here. We have 3 examples here. We're going to go through those pretty quickly. As I just make these number lines really quick. All right, one thing that I like to do is I like to always have my variable first. The first problem gives me that p is less than -4. Okay, so I have -4. Okay, I'll put the number 0 where it would go. Okay, so I am going to here, because it's less than, it's an open circle. Is 0 less than -4? Nope, it goes the other way. Here's my graph. And I should have used a different color. Like I said, I like my variables first, so I want to make sure that I put my variable first. Okay, and when I do that, Control-Z, when I put my variable first, it's going to be important that I make the inequality sign follow what it's doing. Okay, so as you see that the arrow is pointing to B, I want to make sure that wherever I move B, it points to B. So B is less than or equal to 82. So I have 82 here, where 0b over here. Okay, this would be a closed circle because it's or equal to. And then I'm going to shade to less than. Okay. Number 3, I want to rewrite it so that my variable is leading to open at h. So I'm going to make sure it opens at h. So I have h is greater than -5. So I have -5 here. 0 would be over here. In this case, I have an open circle. Okay. And going to where it's greater than, so 0 is greater than -5, going in that direction. Here's my arrow. Okay. All right, make sure you pay attention to whether your circle is open or closed. Make sure that you are shading in the correct direction. All right, a few more here. Just writing inequalities given situations or graphs. Define the variable when necessary. It says, to do well on a test, you need to spend at least 45 minutes studying. Okay, so time studying, I'm just going to use S. So here it says at least 45 minutes studying. Important that at least, you have to think when you're writing these inequalities, if I did just that, does it work? Okay, so you're basically trying to think of, is it or equal to? Okay, because you want your time to be more than 45. I mean, this isn't saying like if you spend too much time. So, but now we're asking, can we spend 45? And the answer to this is yes. That word at least says that that's the minimum, but you can do that much. Okay, if you said I need at least $5 to eat at McDonald's, you're saying, okay, I can make it work with $5. I'll be okay with more, but so in this case, you're saying you can do well with studying 45 minutes if that's all you want, but like if you can get more, do it. Number 2 says the car can go at most 120 miles an hour. Okay, so the speed of the car, I'm going to use M. Okay, at most 120. So now as we're thinking about this, can the car go 120 miles an hour? The answer is yes, at most. Okay, but we know that's as high as it can go. So M, whatever that miles per hour is going to be less than 120 or equal to 120. And that's it. Okay, looking at number 3. Now we don't have a situation, we just have a number line. On this number line, we see a closed circle going to the left. Pretty easy here. Closed circle going to the left. Less than or equal to. And so we're going to just put a variable here. I just put X. There's no situation to think about. And then where is our boundary? Our boundary is at that -1. That's where it starts. So X is less than or equal to -1. That's how this graph would look. Number 4, we have, again, our circle's open and it's going to the right. Okay, so it's open and will not have an or equal to. It's going to the right. Our boundary is at -3. So we'll say X is greater than -3. All right, that's our intro. Make sure I'm doing this. To inequalities. We should have been able to give a number of solutions to an inequality, and then we should be able to show all the solutions to inequality. We do that using a graph or number line. Okay, see ya.